Hey guys, and now we're going to solve for integrating factors involving differential equations. Now there are two cases that you must remember when solving integrating factors. Case 1 is when the partial derivation of m with respect to y minus the partial derivation of n with respect to x can be divided by n such that the result is a function of x f of x. It follows that, let's say, v is equals to e raised to the integral of f of x dx. The second case is when the partial derivation of m minus the partial derivation of m with respect to y minus the partial derivation of n with respect to x can be divided by m such that the result is a function of g of y. It follows that, let's say again, b is equals to e raised to the integral of negative g of y dy. Now, we must remember these two cases because they will be the basis on which our integrating factors will go. Now, after getting the integrating factor using the right case, we can now multiply it to our original or first equation in order for it to become an exact DE. Now, let's go with our equation or problem. Now, this is the problem that we're going to solve using the integrating factors of first order differential equation. First, we're going to simplify each of the function in order to easily maneuver and allocate for the partial derivation of each function that we're going to use in the equation. So 4y squared plus 10xy minus 4y plus 8tx plus 2x squared plus 2xy minus x dy. Now that we've simplified the equation, we can now look out for the partial derivation of m with respect to y, which is equals to 8y plus 10x minus 4. Along with that, we can also look out for the partial derivation of n with respect to x, which is equals to 4x plus 2y minus 1. Now, as we can observe, this is not an exact differential equation, so we have to find the integrating factor. And since it is not equal, we are going to subtract the partial derivative of m with respect to y minus the partial derivative of n with respect to x equals to 0. So substitute the values. 8y plus 10x minus 4 minus 4x minus 2y minus plus 1, which is equals to 0. Now, after solving this problem, we can find commonality between which of the function that we're going to use as the basis for the case that we're going to undergo. So, solve for the like terms. 8y minus 2y is equals to 6y. 10x minus 4x is equals to 6x. 10x minus 4x equals to 6x. And negative 4 plus 1 is equals to negative 3. Now, as we can see, the resulting function has a commonality with the n function. So now we're going to divide 6y plus 6 minus 3 to the n function in order to get our integrating factor. So we're going to use the case 1, so 1 over n and 6y plus 6x minus 3 will be simplified as 3 multiplied by 2y plus 2x minus 1 equals to 0. So substitute the value of n, 1 over x, 2x plus 2y minus 1. As you can see, the value of the n function and the function that we get by subtracting the partial derivative of m and n is similar. So we're going to cancel them out, resulting to 1 over x multiplied by 3 equals to 0. Now further simplifying this term will become 3 over x equals to 0. Now using the result of this process, we can now surmise what our integrating factor will be using the case 1 analysis. So integrating factor is equals to e raised to the integral, and since we use the function of n, so we're using the case 1 form of getting the integrating factor. So e raised to the integral raised to 3 an integral of dx over x. We just simplified the form in order to solve it more easier. So e as is 3 integration of dx over x is equals to ln x, and now we're going to further simplify this form by changing the formation of our exponents. So e raised to ln x raised to 3, e and ln will be cancelled out, resulting to x cubed as our integrating factor. Now using this integrating factor, we're going to multiply and combine it with the original equation. Now using our integrating factor, we're going to multiply it to our simplified original equation, which is 4y squared plus 10xy minus 4y plus 8 dx plus 2x squared plus 2xy minus x dy. So multiplying it will become 4x cubed y squared plus 10x to the power of 4 y minus 4x cubed y plus 8x cubed dx plus 2x to the power of 5 plus 2x to the power of 4 y minus x cubed x to the power of 4 dy. Now using this new equation, which can be solved as the same with the process of the original equation, we're going to look for the partial derivation of m with respect to y, which is equals to 8 x squared plus 10 x4 minus 4x cubed, and we can also get the partial derivation of n with respect to x, which is equals to then x to the power of 4 plus 8x cubed y minus 4x cubed. Now, as we can observe, it is now an exact differential equation. Now, now that we found out that this is an exact equation, exact differential equation, we can now solve it as it is. So, there is a function of x which is a partial function of x which is equals to the function of m which is 4x squared y 4x cubed y squared plus 10x fourth y minus 4x cubed y plus x 8x cubed dx. So we're going to integrate this in terms of x. So we're going to set out the y variable in order for us to integrate this more smoothly and easily. So 4y squared integral of x cubed dx plus 10y integral of x fourth dx minus 4y 4y integral of x cubed dx plus 8 plus 8 integral of x cubed dx of x cubed dx. Now we're going to add a generic function in this process since this is an integration in terms of y, in terms of x. So the generic function will be g of y. So we're going to solve for this. So 4y squared integral of x cubed dx will be x fourth y squared plus 10y integral of x fourth dx will become 2x cubed y plus 4y integral of x cubed dx will become minus x 4y plus 8 integral of x cubed dx will become 2x fourth plus the generic function g of y. Using this new equation that we made, we're going to derive this in terms of y. So x fourth y squared will be derived and will turn into 2x fourth y plus 2x fifth 2x fifth minus x fourth plus the generic function which will become g prime of y. Now with this equation we can now use the n function in order to cancel out like terms. So 2x fourth y plus 2x5 minus x4 plus g prime of y, and using the function of n in order to cancel out the like terms. So 2x5 plus 2x4y minus x4. So 2x fourth y will be cancelled out, 2x fifth will be cancelled out, and so as x fourth will be cancelled out, with the remaining of g prime of y, which is equals to 0. Now the integration of g prime of y is equals to g of y, and 0 will be replaced by arbitrary constant, which is c. Now using the result that we get from deriving the new equation in terms of y, we got the result c. So we're going to substitute it to the generic function g of y. So x fourth y squared plus 2x fifth y minus x fourth y plus 2x fourth plus the arbitrary constant c equals to 0. Now we can simplify this answer by taking out x and its lowest exponent. So x fourth is the lowest exponent in the equation. So x fourth multiplied to y squared plus 2xy minus y plus 2 equals to the arbitrary constant c. So this is our final answer. Thank you for watching. See you next time.